Hi. Let me continue with the integration of trig functions. This time we are dealing secant. Secant in. As I said before, I try to after these examples, I try to let you have an idea that how to deal with the trig function in general way. We have done sine, so you could practice cosine. I've done tangent, you could practice cotangent, which is similar. Now today I'm going to teach the secant. You can do cosecant, right? The first one is not easy actually. Secant x dx. This one is not easy to do. Although the result could be considered as a basic formula. When you're dealing with other integrals or in the subject in the calculus, you can directly use the result. But let's see where comes the result first place. Okay, this one might be other ways, but let me do my way. Okay, this is 1 over cosine, right? One over cosine, that's right. And I'm up over cosine again. Times cosine. This is cosine square. Okay, why I do this way? Because I want to create condition for changing variables. This becomes on top becomes the derivative sine. Right? This becomes 1 or minus sine square. Okay, so by writing this way, actually I'm doing this. Way. See, I'm doing this integral. This is you know how to deal with it. This is a 1 minus x, you're right, plus a or b 1 plus u. This is by what is the name of a method? Partial fractions. That's right. So this becomes a integral 1 minus sine x, right? This is 1 plus sine x. And d sine x. Okay. I hope it's a little messy, but okay, now I save time. Partial fractions, right? So this must be half, right? Must be half. Let me save time. I'm not doing it. So this one is a plus, right? Half. That's correct. So this one is equal to this one is equal to 1/2 inside. This is a 1 minus sine x, right? Yeah, integral. And integral 1 plus sine x. Now, here I doing a little tricky that instead of writing this one, I'm writing d1 minus sine x. This and that the same except negative number, right? With negative on side. And then this is a d1 plus sine x. Do you follow? Right? D sine x is the same thing as a d negative d1 minus sine x. D sine x is the same thing as a d1 plus sine x. The reason writing this way, because this becomes a negative log, right? 1 minus sine x. This one is equal to log 1 plus sine x plus c. Then this is equal to 1/2 log. This is 1 plus sine x, 1 minus sine x, right? Plus c. Then this is 1/2. I multiply by 1 plus sine x, both top and the bottom, right? Multiply 1 plus sine x, both numerator and denominator. So this becomes 1 minus sine square, right? This becomes 1 plus sine x square. And this becomes a cosine, right? Cosine square. This is 1 plus square sine. Cancel with this one. So this becomes a log cosine x 1 plus sine x plus c. Do you follow me? This half I'm written here, so cancel with the square. This is a cosine square. Cosine square, this is also a square. Cancel with the half. Become this. And this is 1 over cosine is secant. Sine over cosine is tangent. So that is the result. Let's see. So that is the result of secant integration. The integral of secant is this. Now you can consider this as the basic formula you can use directly. But this is steps. These are steps showing that secant derivative or secant integral is equal to log secant plus 10. Now then, secant square. Integral secant square x. Secant square is equal to tangent, right? That's easy. Nothing. Then secant cube. Secant cube. Reduce the power is not possible. Change the structure doesn't work. So we try this way. This is secant x, secant square x dx. Here I'm prepared for integration by parts, right? This is u, this is dv. So u is secant x, and du is equal to secant x tangent x dx, and dv is equal to secant square x dx. So v is equal to tangent x. Now this one is equal to uv, right? uv is a secant 10, secant x tangent x. v du, v times du minus v times du. This is a secant x times tangent square dx. I'm sorry, there's no room in this. All right, this is secant x tangent x. Then this minus, this is secant cube, right? Secant x minus secant square x minus 1 dx. This is tangent, right? This is tangent. Now this is equal to secant x minus tangent x minus secant cube x, right? Plus secant x dx. Okay, so far so good. This is secant cube. This time this one is this. All right, now this is negative. If I move to the other side, it becomes this is the same thing, right? Move twice. So secant cube x dx is equal to 1/2, right? 1/2 this secant x tangent x, tangent x plus this one is log secant x plus tangent x. Okay, plus c. So that's being done. Everything is okay. So secant this integral is equal to this, in which that you have to use the previous result, which is secant was I couldn't find secant which has been done. The secant is a log of secant plus 10. Okay. Now next one is secant fourth. Secant fourth. I hope you have some kind of experience, how to deal with this kind of function. When you first look at, you have an idea, reduce the power, change the structure, or something else. Okay, here, when you see the even power of a secant, you must have an idea that, I may change the structure. Change the structure into what? This is secant square, right? Secant square x dx. Here is well, I bring tangent square coming, right? This is tangent square plus 1. This is the tangent, right? Now, I changed the name of game. The name of game is x. Here, the name of game is tangent x. So here is no longer being trig function. It's polynomial. So this one is equal to, right? This is 1/3, right? Tangent 3 plus tangent x. Does it make sense? Yeah. Okay. Secant fourth, secant square, secant square, secant square, secant square. Yeah, it's done. Now, secant 5. You must have an idea now how to deal with this. If I bring secant square, as a tangent square plus 1, this is a secant square, right? And then you have a secant cube. It doesn't solve the problem, because you know why? Because this odd number, odd power, you cannot change it to tangent. right? If I change this one into secant square x dx, and this becomes the derivative of tangent, right? But I cannot change this one to tangent because this is odd power. Do you see the problem? Because I can't change this to tangent. So what to do? I think that same thing as consider the dealing with let me see, too many paper. I couldn't find the previous one, secant cube. Where is secant cube? I couldn't find secant cube. Well, let me do it again, anyhow. Okay, let me do it again, anyhow. This I change it to secant cube x, secant square x dx. Now, the reason I'm doing this way, I'm doing this one, the reason I'm doing this way, I'm prepared for the by parts. Because this is my dv, from which I can find a v. This is a u, right? So u is equal to secant cube x, right? Du is equal to 3 secant square, 3 secant x, and the secant x tangent x dx. Sorry for these messy writing. So this dv is equal to secant square x dx. So v is equal to tangent x. So this one is equal to uv. U is this, v is this, right? Secant cube x tangent x. Minus v du. Du is this. Minus 3. This one times this one, right? This is 3 secant cube and the tangent square dx. Yeah. Now this one is equal to secant cube x tangent x minus 3 integral. This is a secant cube x secant square x minus 1, right? dx. I need more papers. Well, it's a little messy. Then this is equal to secant cube x tangent x minus 3. This one times this one is a secant fifth, right? Secant x dx plus 3 secant cube. Okay. Now this side is secant fifth. This side is secant fifth. So this is a 3 secant. When you move there, it becomes a 4 secant, right? Therefore, secant fifth power dx is equal to 1 over 4 this secant cube x tangent x plus 3 secant cube x dx. This has been done, the previous example. So that has been done. Let me find it. Where is the cube? Yeah. See? secant cube has been done. That is the result of secant cube. So we just write over there, then we have this. And can you imagine that secant 7x dx would be the result using this? Okay, and secant 9th x dx will be a result using this one, and so on. You know, that is what I want is that you get the general idea how to deal with these functions. Even if it's tedious, that means it can be done. Now, how about a 6 before 6? Okay, we haven't done a 6 yet. This is rather easy. This is rather easy because this is equal to secant 4th x secant square x, right? This, this is secant 4th x. This is a tangent, no, d tangent x, right? This is d tangent x. So that means that we change the structure. The structure has been changed. So no longer being x, but rather we are dealing with tangent x. So this changes the tangent x. 1 plus tangent x square, right? This is the secant square, right? Dealing with d tangent x. So this integral is rather easy. It's like a 1 plus u square du. It's polynomial integral. So now let me summarize that. Last time we have done tangent, right? Tangent, and we have done secant. And you can do similarly with cotangent, cosecant. Then we are dealing with the combination of these two, right? Combination of a tangent m x secant n x dx. Then we have 4 cases, right? Both are even, both are order. One even, this is even, this is order, or this is even. This order, this is even. Okay, we have 4 cases. Now, let's do the first case. Both are even. Tangent square, secant 4th. Now, you must get an idea. You must have an idea that how do they deal with these kind of integrals in general. So here, I know that secant square dx could be changed to tangent. So this becomes d tangent. This is a secant square dx. So they left over secant square, right? So left over tangent, you have to change it to tangent. Tangent square, this is secant square. This is secant square, tangent square plus 1, right? So that is a new integral. Everything has been changed. No longer we are not dealing with x, we are dealing with tangent x. So here is just polynomial. So this one is equal to 4th, right? So 1 over 5 tangent 5x plus 1 over 3 tangent 3x plus c. So this has been done. C for the even power is very easy. It's different from sine, cosine. Cosine, when you see even power, you have to reduce the power. But when you see even power here, I can change the variables. Okay. Then 1 even, 1 order. 1 even, 1 order. Say this is even, this is order. Dx. this is how to deal with this one. Science how to deal with this one? It's it's not easy. Well, there's two possibilities if you want to change the structure. Change it to tangent. Change it to secant. If change it to tangent, this is secant square. And you take secant square away, then you leave one more secant. So you cannot solve the problem. If you change this one, this is secant tangent. Secant tangent, you take one here, take one there. You'd have tangent square, or tangent cube, and the secant square. And you cannot change everything to secant. So these are not possible. So leftover is changes this one into secant square minus 1 square, right? Secant. So this one is equal to secant 5 dx. No. I'm sorry. Expand this one. This one is secant square, right? Secant square fourth by seventh minus 2 secant 5 plus secant cube x dx. So all these integrals we can do it, even though, well, even is very tedious, but the integration can be done. So it's a problem that we have order power here. Okay, we have done both even, one order. Now how about tangent order? Tangent is order, and secant is even. Okay, switched the order and even. That one is different. It could be very easy, because you know why? Because this is secant square becomes tangent x. This is secant square dx. Secant square dx. And I can everything in front into tangent. This has been already a tangent, no problem. This leftover secant square, a tangent square plus 1, right? Now everything is done. Everything is done. So this one times this one, this is 6, right? Tangent 6 plus 1/4 tangent of x. Yeah. See what the difference? When you have a all the power for secant, the integration is not easy. It's complicated. But when you have all the power for tangent, it's very easy. As long as the secant square is a secant power is even. Okay, the last case is that both orders, tangent cube secant fifth, both are order. This one is not, and it looks very difficult, but it's not, because we know that d secant, this is secant x, this is a secant x, tangent x dx. Understand? This is this. So therefore I take one tangent here, one secant there, associated with dx. It becomes d secant. So this one becomes d secant. I get a little excited. So d secant. So left over what? Left tangent square, secant fourth. But I want everything in terms of secant. So tangent square is secant square minus 1. That becomes tangent square. And the leftover is tangent fourth, secant fourth, right? That's okay. Leave as it is. Then this integration can be done easily. This is, this time this one integral, this one 7th, right? Secant 7x, okay? And minus, this is 1 over 5, secant 5x. See, that's been done. So let me summarize. Okay, we have dealt with this kind of integrations, both order, even and order, and so on. So we have a general idea. We have an idea in general how to deal with this kind of functions. All right. So we have done almost all these basic treatment for the sine, cosine, tangent, cotangent, and secant, cosecant. All right. Hope this is helpful for your calculus study. Thank you for your watching.